Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Solo by Koktislav. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have a digit in a cage counts how many of the up to 9 3x3 squares that include the cage cell contain no other instance of that digit. For example, if row 2, column 3 was a 4, then among the 6 3x3 squares that include this cell, exactly 4 contain no other 4. So the 6 3x3 cells would be this one, this one, this one, this one, and then these, and this. So those are all the 6 3x3 boxes that contain that cell, and of those, 4 of them contain no other 4. So that's interesting. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Well, this one's simple. There's only one 3x3 box that can contain it, and exactly one contains no other one, so this must be 1. So that's easy. On the edges... On the edges, you'll have what? There's 1, 2, and 3. So this must be 2 or 3, and this must be 2 or 3. So on the edges, you only have 1 through 3 available. So that's 2 or 3, and this is 2 or 3. This, I think, has to be 1 or 2, right? You have 1 3x3 box and 2 3x3 boxes, so that's 1 or 2. This is 1, 2, or 3 also, right? 1, 2, and 3. Yeah. And this is also, anything on the edge is 1, 2, or 3, I think, right? So we have 1 3x3 box, 2 3x3 boxes, and 3 3x3 boxes. So this is 1, 2, or 3 also. So we have 2 or 3 here. 2 or 3 here. These are also 1, 2, and 3, right? So these have to be non-1, 2, or 3. That's interesting. So this is going to be, right, we have 1 and 2 3x3 boxes here. So this is 1 or 2. This is 1, 2, or 3. This is 1, 2, or 3. Right, we can't have anything else yeah, it has to include that, and it can only go this way. Right? Once you go one step this way, obviously it doesn't contain that cage. So this has to be at least 4. So we have 1, 2, 3. So we have 1 here, 2 here. You can't go further this way. Yeah, that would be 3 this way. And then 4 as a corner. So it could be, right, it can be in the right. So it could be in the center position. It can be in the right center position. It can be in the top center position, or it can be in the upper right corner. So this is 4. That means none of those boxes also contain a 4. So this does not contain a 4. None of these can contain a 4. So 4 cannot be any of these cells. So we know 4 in box 2 has to be one of these two. 4 in box 6 has to be one of these sets. And 4 in box 5 cannot be here. So it has to be one of these cells here. Anything that's 2 away. So this could be 1. So this also has to be 4, I think, right? So again, it could be in the center of a 3x3 box. It can never be the top right corner here. It's not big enough. Can't be the right center. Can't be the top center. Can't be the bottom right. Can't be the top right. So that's 4 cells there too, right? Right. So this is 1. You have 2, 3, and then four 3x3 cells at most. So this has to be 4, and it can't, because it can't be 1, 2, or 3. This is one of these is 1, so this can't be 1 here. One of these is 1, so this can't be 1 here. So this can't be 4. 4 cannot be here. It can't be here. So 4 has to be one of these two. Can't be here. Can't be here. So it has to be one of these 3. That's interesting. These are up to, so you have 1, 2, 3. So all in the middle row, or 4, 5, 6. So this cannot be, this is up to 6. It can't be 1, 2, 3, or 4. 4 can't be here, 4 can't be here in box 1, so 4 has to be here. So only 4 of the 3x3 boxes, and there are 9 of them for this, can contain a 4, or contain no other 4. So obviously this contains no other 4. There's definitely going to be a 4 in this one. There's definitely going to be a 4 in this one. Okay, so let's just go through the... Okay. Also, these have to be 5 and 6. So the remaining digits in box 1 are 7, 8, and 9. Okay, so 4... This has to be 5 or 6 also, because of the 1, 2, 3 triplet in the box, and the 4 in the column, in the box also. So this is 5 or 6 as a pair. This could be up to 9. This could be up to 9. This could be up to 9. 4. Well, let's mark the ones. So there's this. There's this, and both of those contain a 4. We are guaranteed a 4 here in this one. So that's 1, 2, 3. What about this? We are guaranteed a 4. We don't have a guarantee of a... Well, actually, we are not guaranteed a 4 there necessarily. Okay, let's go through all the possibilities. Okay, so the blue does not contain a 4. Yellow. What happens if we have yellow? So the blue does not contain a 4. We know red does. I don't know about light, though. We know red does, dark does, because one of these is definitely a 4. What happens if it's in that position? Yellow. We don't have a guarantee. Red obviously does. So we've done blue, yellow, red. pink. Hmm. I don't know if this is going to be helpful. Again, we don't know about light. You could have a 4 here and then a 4 here. Oh, wait, hold up. This can't be 4. Never mind. So since this is 4, neither of these could be 4. Okay. Right, so that's guaranteed there. That's guaranteed there. This can't be 4. It could be up to 9. So this is 5 through 9. This could be... Well, we have 1. Okay, so it can never be 9. Because obviously the 3x3 box it's in cannot contain... is definitely one that will not contain... Oh, wait, no, it could be 9. Never mind. So this is 5, 6, 7, 8, 9. This is anything from 1 through 9 here, technically. Okay. 2 out of 1, 2, and 3 are along in column 2. Actually, 3 has to be one of the digits in column 2. So this is 1 which does not contain 2 or 3. 2 does not contain 2 or 3. So whichever way it goes here. So let's say this is 2. So this would be 1. This would be a second 3x3, and this would be the third 3x3. If it's ever in one, if the 2, say if this is 3, if it's 3, it's in none, the 3 is not in any of these cells. So therefore 3 would have to be one of those. However, if it's 2, it cannot be in this one and in this set 3x3, so it could be in this one. It would. We know that the 2... That doesn't help us much. That's not as restrictive, so we don't have that much information there. Can this ever be 1? Yes. Can this ever be 1? Yes. Okay, that's interesting. So this one only has this set and this set of 3x3s that contain 1. So it would have to be the yellow set, obviously, containing no other 4. So there's guaranteed no 1 here. Because for this cell, if this is 1, that means only one 3x3 box contains no other 1. That means this... Oh, wait, no, that means 1 has to be here. Okay. Right. 1 has to be here because there's a duplicate. Otherwise, this is the 1 for 1 in this cell. In this cage. And these 2 3x3 boxes have to contain another 1. Both of them. So both the yellow and the red has to contain a 1. So 1 is guaranteed to be here. That's interesting. So 1's guaranteed to be one of these 2. This is the same logic here. So 1 is guaranteed to be one of those 2, right? Because if this is 1, the 1 3x3 box that does not contain another 1 is this one, right? And then this must contain a 1. which means 1's here. If this is the one that does not contain a 1 is here. This must contain a 1, and this must contain a 1. And obviously it would if it's there. So that's 1. This is 1. So 1 cannot be here or here. 1 in box 5 has to be one of those 4 cells. That's interesting. 2 and 3 are not as helpful. 5 and 6 is interesting. Right? So in 6, that if this is 6, that means all 6 of these 3x3 boxes cannot contain a 6. And then we have pink. We have green. And then what I'm using is I'm using the relative positioning of the cage as the color. So none of these would contain a 6. If that were the case. So 6 would have to be one of these 2. Or if this were 6, then 6 would have to be one of these 2. What about 5? That's interesting. So 5 obviously could not be in this 3x3. It could be here. It cannot be in this, in the pink 3x3. Because if it were in any of the pink ones, that would mean that it would have to be, it would essentially have to be one of these 2. And then the medium gray 3x3 would contain that also. So for the 5, it has to be, I think, in the red or the light 3x3. I guess it could be in the gray 3x3. Okay, so it could be the red 3x3, the green 3x... No, can it be the green 3x3? So say this was 5. You obviously don't have a 5 here in the yellow. You cannot have a 5 in the pink. If you had a 5 in the pink, it would be not here. It would have to be one of these 2, right? But that would also be in the 3x3 contained in for the medium cell here. So that's why pink doesn't work. So you have the same... If you have media, so the ones that are only ones that are not... So if you have green here, if you have a 5 here, 5 cannot be obviously any of these. 5 could be any of these 3. But those are in other 3x3 boxes, so that you wouldn't have 5. So 5 would have to be then... Interesting. 5 would have to be here, here, or here. And it can only be in one of them. Okay. Let's fill in the rest of, like, row 1. This is 4 through 9. Obviously, no 4 here. 5 through 9. 5 through 9. We have 4 through 9. Okay, this 4 through 9. 4 through 9. 4 through 9. 4 through 9. No 4 here. 4 through 9. 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 No 4. 5 through 9. 5 through 9. 4 through 9. 4 through 9. This is 5 through 9 in box 3, 5 through 9 in box 7. So one of these has... Okay, this can't be 4. Because of this 4 here. This can't be 4 because of this 4 here. Ooh, this is 3. So, what happens if we try to make this a 3? That means all 3 of these boxes could not contain a 3. But where is the 3 in box 9? It has to be one of these cells here. So this can't be 3. This must be 2. So this is 2, which makes this 1, which makes that 3. So that makes this 2, which makes this 3, which makes this 2, which makes this 3, which makes this a 1-2 pair, which makes this 3. So 2 must so that means 2 of these 3x3 boxes do not contain another 2. So this can't be 2. So this can't be 2. So 2 has to be here. Okay. So 3 of these boxes, 1, 2, 3, cannot contain another 3. So this cannot be 3 here or here. So this is 3 here. 2 of these boxes cannot contain a 2. So neither of these can be 2, which is possible, which means this must contain a 2. So 2 has to be here. So this is 7, 8, or 9 here. We have 2 here. 2 can't be here. 2 can't be here. 2 must be one of these 2. 3 cannot contain... 3 of the 3x3s cannot contain another 3. So all 3 of these can't. So 3 can't be here, so 3 must be here. Where is 3 in box 9? Can't be here, can't be any of these, so this must be 3 here. 3 has to be one of these 2 in box 5, and 3 must be one of these 2. Can't be here, because this is 1, 2, 3 3x3 boxes, not containing another 3. So this is 3, which makes that a 3. There's no 3 here. So 1 has to be one of these cells. Okay. What else do we have? 2. Can this be 2? 1. Yes, it could be. 2. And then this would be 2. This, if this is 2, that's saying 1, 2. That doesn't work. So if this were 2, if we tried to make this 2, we know one 3x3 box doesn't have a 2, doesn't have another 2. If this doesn't have a 2 here, that means this can't be 2. That means this 3x3 box also does not contain a 2, which is not possible, because it would be here. So that would force it to be 3. So this can't be 2 then. This is 1. This is 2. So this is saying 2 3x3 boxes do not have a 2 here. So this doesn't have a 2, another 2, this doesn't have another 2. So this can't be 2 here, which forces this to be 2 here. That means 2 can't be here, here, or here in box 5. It must be one of these 2. It must be one of these 2 in box 2 then. Okay, so 1 has just this box, which doesn't have a 1. This one does. This one does, obviously. So this can't be 1. 1 is one of these 2 here. 1 can't be here. 1 is definitely one of these 2. Okay. Hmm. 1 cannot be here. So this can't be 1 because of this 1 here. Can't be 2, can't be 3. Could be 4 through 9. Okay. So what other aspects do we have for these boxes? So this is pretty much done. All the 3s are located. So again, this one only has one 3x3 box it could be part of, so that's why it's 1. This has 2. Oh, 1, 2, 2x2 boxes that does not have a 2, so this must be a 2 here. Which means this can't be 2, so this is 2 here. So there's no 2 here. We have this 4. That's interesting. Huh. So this has one 3x3 box that it's part of. This has 3x3 boxes it's part of, and this one doesn't have another 2, and this one doesn't have another 2, but this one does. So that satisfies that. This has 3x3 boxes, all of which does not contain another 3. Same with this, 3x3 boxes, all of which does not contain another 3. This has 2. 1, 2. That does not contain a 2. This has 1, so it's just this 1, which means there's a 1 here, because this must contain another 1, and this must contain another 1. 3 here. 1, 2, 3. 2 here. 1, 2, and this one contains another 2. We did 3 here, 1 here. This does not contain a 1, but this does. 3, 1, 2, 3. This has 2. This is obviously one of them. This is another one that does not contain a 2, and this one contains a 2. So those are all satisfied. 4 is all satisfied also. This does not contain 4. Neither does this. Neither does this. And neither does this. And it's the same one for that. So this is interesting. Obviously, this contains a 4 and this contains a 4. So... let's see, there's going to be 9 in total. So that means 3 more must contain a 4. Three more must contain a 4. Obviously, this one does not contain a 4. So what happens if 4 is here and here? You'd have this contains a 4. This contains a 4. Sorry, this one does not contain a 4. This one contains a 4. So it does not count. This one contains a 4. Does not count. So that's 1, 2. This one contains a 4. 3. Does not count. This one contains a 4. So that doesn't count. But then we are guaranteed there's no 4 in one of these two cells. So this would not contain a 4. So we have 1 that doesn't contain a 4 here. This does not contain a 4 here. This does not, again, blue, yellow does, red does. Green does not. Pink does not. Orange does. Dark does. medium does not, and light does not. So that would be 1, 2, 3, 4, and 5 of the 3x3 boxes does not would not contain another 4. So that's not possible. So at least what happens if both of these are 4 here? That's interesting. Okay, if both of those are 4, we have again blue satisfies that. So 4 cannot be here and 4 cannot be here then. So blue satisfies there. Yellow also satisfies. Red does not. Green does. Pink does. Orange does. That's already too many. Right? We have blue, yellow, green, pink, and orange, all containing 4. So it must be there's a 4 here and a 4 here, or a 4 here and a 4 here. Okay, so what happens if there's 4 here and 4 here? Okay, blue does satisfy, yellow does not, red does not. Green green we don't know. Because we just eliminated 4 here, but this could still be a 4 here. And in fact, probably, actually it has to be. Because this would be 4, this would be, okay, so this would then be 4 if that's the case. Okay, so if this is 4, 4, okay, so if this is not 4, then this has to be 4 because there's no other 4 available in row 4. What happens if we try going the other way? So say this was 4 and this was 4. We don't have another 4 available in column 4, so this would have to be 4. So let's try this first. I think it has to be that way then. So this can never be a 4 here. So let's see if this is satisfied. We have blue here. Yellow is satisfied, so that's 2. Red is not. Green is, that's 3. Pink is, that's 4. Orange is not. Dark is not. Medium is not. And light is not. So that satisfies that. And then it should satisfy it the other way. So the question is, if this is the setting of the 4s, how many of these 3x3 boxes do not contain a 4? So that would mean 4 would have to be here and here. Okay, so then, so this, okay, so light would not contain a 4. Light would contain another 4. Medium would not. Dark would not. Orange would not. Pink would not. And green would not also. So this cannot be 4 here then. That's already, so dark 1, medium 2, light wood, obviously. But then we have orange 3, pink 4, and green 5, all not containing another 4. So that's why that can't be 4. So then we know this has to be 4, and this has to be 4. And this, since this is not 4, where's the 4 in row 4? It has to be here. So this is 4. Which means none of these are 4. This can't be 4. This can't be 4, which leaves a 4 here. Oh, this was always going to be 4 then, huh? That means 4 could not be here. 4 cannot be any of these. So this must be a 4 here, which means this can't be 4 here. This is 4 here. We should have 9 4s, right? 1, 2, 3, 4, 5, 6. So this satisfies this again because we have 1. So we have 1 that doesn't have a 4. This does. This does. Okay, so obviously remove that. Yellow does. Red does. Green does. Pink does not. Orange does not. That's 3. Dark does. And then medium does not. And then light does. So that satisfies that. So this can't be 4 anymore. Okay. Where is 1 in box 9? It must be one of these 2 cells, which eliminates 1 here, so this must be the 1 here. So one of these is 5, one of these is 6. One of these is 5, one of these is 6. 7, 8, or 9. Yeah. Okay. Can it be 9 in these corners? Probably, right? So, if this is 9, that means every 3x3 box that it's part of does not contain a 9. That's not going to work, because then 9 would have to be here, and 9 would have to be here, and there would be no 9 possible here because of the 9 3x3 cells. Squares that contain that cell does not have a 9. So then it would have to be one of these, but then because there's a 9 here and a 9 here, it can't be here. So then box 5 would not have a 9. So because of that, this cannot be 9, and this can't be 9. What about 8? That's interesting. 8 3x3 boxes. So you say you had an 8. The overlap would be red, yellow, blue, orange, pink, green, light, medium, and dark. So 8 would have to be in blue or light. So say it was in blue, right? Then that means this couldn't be 8. You'd have to have an 8 be here. Oh, yeah, it would have to be blue, right? Because there's no other place for it here. So this would have to be 8, which means this is not 8. So 8 would have to be here, so there's no 8 here, no 8 here, no 8 here. That would force this to be an 8. That's interesting. Okay, so then if 8's here, this is 8 here, and it would force 8 here. And would that work? I don't know. Maybe? Blue, yellow, red. Oh, there's no possibility for 8 in column 6 then. Because these, yeah, so that doesn't work. So this can't be 8. Yay, we figured that out. Specifically because this is 2, 3, 4 here. I don't know about that one then. Maybe? If this were 8, then 8 would have to be here. That seems like it works. Remaining digits in row 3 are 5 through 9. Okay. Here it's 5 through 9. Here it's 5 through 9. Oh, that's interesting. One of these is a 5. So doesn't that make that a 5 there? Okay, so say this is 5, right? We have... Actually, I don't think this... Well, it could be. I guess this could be a 5 here. Let's look at this side, because this one's restrictive. So let's... If we try 5 here... this obviously doesn't contain a 5. Red obviously doesn't contain a 5. This could. But if it's part of green... Okay, so let's do all the 3x3 boxes. So we have green, this is pink. And then we have medium and light. So the problem is it can't be part of these cells because then that would be part of multiple 3x3 boxes that would have multiple 5s, and we only can have 1. So this would have to be 5 if that's the case. But this could be the 5 also, right? And you could have a 5 here. And that would satisfy that, right? So these 3x3 boxes are here, here, green, pink, yellow, and red. So then one of these two would be a 5. That is interesting, though. We know then one of these two is a 5. If this is 5, one of these two is a 5. And if this is 5, only this can be 5. So the question is, can this actually be 5 here? Huh. So can this be 5? What are the corners? Blue, yellow, red. Oh, where's the positioning for each of these 5s? So if this is 5, that means 5 would have to be here. So then 5 could not be any of these. 5 would have to be one of these two. Okay, so that would be 5. That seems okay. What happens again if this is 5 then? Let's try specifically with this one. So if this is 5, then this is 6, this is 6. 5 appears in this 3x3, this 3x3, this 3x3. Or, sorry, does not appear in any of these 3x3s. Not here, but it does appear in this one. So then 5 is one of these two. Which means this is 5 here. So it cannot be 5 here or here, so this must be 5 here. That means one of these 2 is a 5, one of these 3 is a 5, then one of these 2 is a 5. And then this not being, I guess this can't be 5, this can't be 5, so 5 has to be one of these. So this cannot be 5 here, so this must be 5 here. 5 here, 5 here, 5 one of these 4. Any of these 5. Okay, so 6 cannot contain a 6, so it can't be 6 here, no 6 here, no 6 here. Oh, that's interesting. None of these can be 6s. Oh, well, that's a contradiction. So this 6 not appearing in any of these 3x3 boxes means 6 has to be here. But then this 6 also cannot appear in these 3x3 boxes because we only have 6 of them available. 2, 3, 4, 5, 6, and that's a contradiction. So that's why this can't be 5 here. So we know this is not 5, this is 6, which makes this 5, which makes this 5. Okay, so this cannot be 5, no 5 here, no 5 here, no 5 here. This 6 cannot appear in any of the 6's, 6 3x3 cells, so no 6 there, no 6 there. This can't be 6 here, no 6's there. So no 6 here, 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 and I think that's it, right? So we already have this 1, 2, 3, 4, and 5, 6. So 5 is one of these two cells. Because this is guaranteed no 5. If a 5 is one of these cells, it would be part of multiple cells, so this can't be 5 here. This has to be a 5 here, which means this can't be 5 here. So this has a 5 here. And then the other ones, let's see. So then orange, pink, and green cannot contain a 5. So this 5 only cannot have a 5 here, could have a 5 here, cannot have a 5 here, cannot have a 5 here, cannot have a 5 here, could have a 5 here. So one of these is a 5. Because if a 5 were here, it would be part of this 3x3 box and this 3x3 box. And then we would no longer have 5 3x3 squares that don't have another 5. So 5 can't be here, 5 can't be here, 5 can't be here, so 5 has to be here. Since 5 is here, that means this 3x3 box is the one with the 5. So we have orange, pink, green. And this would be medium and light. All do not have a 5. So you cannot have a 5 here or here. So this cannot be 5, and this can't be 5. So 5 in box 2 has to be one of those two. Okay. So 5 is one of those two. 5 is one of these two. So that means in box 5, 5 has to be one of those two here. In box 8, 5 has to be one of these sets. If 5 is here, 5 is here. So 5 can be one of these 4. 5 is definitely one of these 3. That's interesting. 5 is definitely one of these 3. Okay. So what happens if this is 5? If this is 5, this is guaranteed to be a 5 too. This can't be 5. How many 3 by 3 boxes do we have? We have red, no yellow, no blue. Orange works. Dark works. That's 3. Pink works. Green works, so that's already 5. Right, we have red. We have orange. We have dark. We have pink. We have green. So then light must contain 1. Medium must contain 1. Blue and yellow already contain a 5. So then this would be 5 if that were the case. That seems like it works. What about 7? Does 7 work? If we have 7 here, obviously 7 cannot be here. Red. Yeah, I guess we just figure out where the 7s could be. Yellow, blue. So it's definitely 7 has to be part of blue because 7 can't be here, and then it must be part of this one of these 4 in box 2. What about orange? Orange seems possible. Pink, green. Green is already satisfied, and pink. Oh wait, no. So yeah, other way around. So we're looking for ones where 7 has to be in the set. Has to be in the 3 by 3. Light. Medium. And dark. Okay. We know in box 2, blue contains 1. So that removes 1 3 by 3 square that cannot contain a 7. Sorry, that must contain a 7. Um, cannot be 7 here. That doesn't seem to be that restrictive, unfortunately. Can this be 8? This digit cannot be 1. Cannot be 2, 3, 4, 5. So this is 6 through 9 there. This can't be 5 anymore because of 5 in the row. This can't be 5. So one of these 2 is a 5 here. Can this be 5? I think so, right? Let's try. What happens if this is 5? Well, we know 5 can't be here, so blue satisfied. Yellow satisfied. Red might not be. Green is satisfied. Pink is satisfied. Orange is satisfied. Dark already has a 5. But medium is not a 5. Does not contain a 5. So that's blue, yellow, green, pink, and orange, and then medium. That's 6 with no 5. So that's not satisfied there. So this cannot be 5 here. Which means this must be a 5 here. This must be a 5 here. So there's no 5 here. There's no 5 here. So this can't be 5. 5 in box 9 has to be one of those two. Interesting. Okay. Huh. 6 again cannot be any of here. 1, 2, 3, 4, 5, and 6. So 6 has to be one of these two, which means this can't be 6 here. This is a 1-6 pair here. Interesting. That eliminates 1 and 6 in the rest of the box, so this must be 7, 8, and 9 as a triplet, which eliminates 7, 8, and 9 here, so this is 6, which eliminates 6 in the rest of the row. Where is the 6 in box 3? It has to be here. This also can't be 7, 8, or 9. It's 1, which eliminates 1 here. This has to be 7, 8, or 9. 6 is here. 6 cannot be here. So this is 7, 8, or 9. And this can't be 6. Where's 6 in row 4? It must be here. This can't be 6, so one of these 4 is 6. This can't be 6 here, so one of these 2 is 6. This has to be 7, 8, or 9. This cannot be 1 through 4, 5, or 6. So this must be 7, 8, or 9 also. Okay. Can this ever be 6 then? Say this was 6. This doesn't contain a 6. But orange will, blue will. Going this way contains a 6, right? So medium will, light will. Yeah, that doesn't work. So this cannot be 6. This is 7 or 8 here. This is 1, 6, 7, 8, 9. No 6. So 7 or 8 is here. Interesting. Doesn't... it's not true. If it's 8, the 8 has to be here. Because every other one would have to not contain an 8. 7, though, is interesting because that changes. Okay, what about this scenario? So this is actually the hard part of the hard puzzle here. Everything else is kind of logical and sort of flows. It's really just these two, or these three, I guess, that are a little bit... Well, this was a little hard here already. So 1 through 4 was actually fairly easy. And then the 5 and 6 parts takes a decent amount of logic. And now we have... This is even further. Okay, let's look at all the 3x3 boxes around here. green, pink, orange, dark, medium, and light. Okay. What we do know is this digit, let's make it A, has to be here, and then has to be here. What about here? It has to be one of these two. Can't be here, so it's one of these 4. Okay. So if it is 9, that means none of these can be 9. So this would be 9 here in row 3. It would be one of these 2 here. That seems fine. Could not be here in box 4, so 9 would be here. So let's just try. If this is 9, this is 9. That means none of these could be 9, so this is 9 here. Cannot be any of these, so this is 9 here. That seems fine. 9 can't be here, 9 can't be here, so 9 would be here. That means this can't be 9, this can't be 9, so 9 would be here. Therefore, 9 would be there. I think that's pretty satisfied, right? 9 is one of those two, 9 is one of those. Huh, so it could be 9. Okay, not so great for that. What about 8? If it's 8, we're looking for contradictions here. That's the whole point for this. That means one of the corners has to have an 8. So this must be an 8 here. Okay. So this would not be an 8. If it were an 8, again, it would be 2 3x3 boxes that would be eliminated. So then there would only be 7 3x3 squares with no other 8. So 8 has to be here, and then 8 has to be here in that scenario. That seems like it works too. So we have 8 here. This can't be 8, so this would be 8 here. Which means these two can't be 8, so 8 would have to be here. No 8 here, no 8 here, no 8 here, so 8 would have to be here. No 8 here, no 8 here, so 8 would have to be here, which would mean 8 is here. So that's satisfied. Interestingly enough, yeah, both of these would be 8, right? 7. So basically, like, okay. So if this were 9, again, 9 would have to be here. Okay, so let's... So far, where has A been, essentially? Let's remove all the A's. Except for this one. So this is, if this is 9, this has to be 9 here because these can't be 9. These can't be 9, so 9 has to be 9 there. These can't be 9, so 9 has to be 9 there. That means 9 can't be here, 9 has to be 9 here. Which means 9 can't be either of these two, so 9 has to be 9 there. Which means 9 is guaranteed to be here, and then we don't have anything extra here. So far, we have this is 9, this is 9, this is 9, this is 9. So these are the 9s. Okay. So we'll mark those with A's. This is A, and this is A. Oops. We should do that without the 9. A, and A. If this is 8, This is 8. Because 8 has to be in the corner. So it doesn't, it only removes one 3x3 square total. And it cannot be in the corners here, here, or here, so it has to be here. So this is 8, this is 8, which means 8 cannot be here. 8 can't be here, 8 can't be in any of the rest of box 4, so this is 8. Which means this can't be 8, cannot be here, so it has to be here. 8 can't be here or here, so 8 is here. No 8 here, here, or here, so 8 is here. So these are all the same, except for this one. This was not the A. So then you would have 8 not be here, not here. It would have to be here. So then A could be one of the, would have to be here and here. So we have A can be one of these two, and it can be here or here so far. But these are the ones that are solid in their box. What about 7? Hmm. Hmm. Seven's a little more difficult. Okay, so 7 cannot be here. I don't think 7 can actually be here either. 7 cannot be here, obviously. Cannot be either of any of these three. So 7 would have to be here or here. Can 7 be here, if that's the case? I don't think so, right? So that means this would contain... So this would be the 7, which means there could not be 7 anywhere else in these. So because they would eliminate this 3x3 box and this 3x3 box from having two other 7s. So that means no other 7s could be here. So this would have to be 7 here. And 7 here. This would be 7. So this couldn't be 7 here. No 7 here. Or here, or here. So 7 would have to be here. You'd have a 7 here, a 7 here. I mean, that seems like... Okay, so this one does... This would not work, though, as a 7. Right. So the problem is this would have 1 7, but then this 3x3 box would have a 7. This 3x3 box would have a 7. This 3x3 box would have a 7. So that's already 3x3 squares, which already contain a 7. So that means there's only 6 in those. So that does not work for 7 there. 7 does not work here, obviously. It can't be any of these. It can't be a single corner by itself. So if there's a 7, it has to be one of these areas. Okay. So it would be 7 here or 7 here. Huh. That seems possible. Hmm. Okay, well that's interesting information. I guess let's keep the A's for now. That's just interesting information to have. What about for this one here? Dark. So, okay. If this is 8, we know where the other 8 has to be, right? So if this is 8, that means only one of these 3 by 3 squares can contain an 8, and it has to be in the corner. So it would have to be here. So if this is 8, this would be 8. Obviously, this could not be 8. It could not be 9 either, because this 9 would guarantee this has to be 9 here. So this would have to be 7. This 8 means none of these are 8, so this would be 8 here. So 8 could not be here, so 8 would have to be here. No 8 here. 8 is one of these two. This can't be 8, so this can't be 7 or 8. This is 9. Seven could not be here, so that would force a 7 here. Then none of these could be 7, so this would not be 7. That's 9. This is 7 here. That's 5. So none of these could be 7 because this is the 3 by 3 box here and here that contain another 7. So this would be 7 here. This would be 6. This would be 1. This would have to be 1. That would be 8. Okay. This would be 7 here. This would be 9. No 7, 8, or 9, so it's 6. This is 9. So far, this is looking okay. 6, 1, 6. So this is a 1, 9 pair. Okay, so 7 cannot be either of these. So this must be 7 here. This can't be 7 or 9. It's 8. I mean, this looks like it's fine. One of these two is 8. We have, what? 5, 6, and 9 here. This can't be 5 or 6, so that's 9. This becomes a 5, 6 pair. This is 8. So no 5, 7, or 8 here. This is 9, which makes this 7, which makes this 9. This is then 7. No 5, 7, or 8, so it's 9, which makes this 5. So this has to be 8. 5, 6. This can't be 6, 7, 8, or 9, so that's 6, which makes this 5, which makes that 6. And I think this might be a contradiction here. So this has red. It does not have yellow, does not have blue. Actually, it might be okay. This is green, pink, orange. Dark, that's 5, and then it doesn't have, that actually works. Dang it, okay. This looks like it satisfies it, so maybe that's the solution. Okay, so then what happens if we try to have... What happens if we try to have 7 here? So if we have 8 here, this can't be 7. Sorry, this can't be 8. So that would force this to be 7. So let's try just having 7 here. So I guess this is the one where it breaks. Okay, I don't know. Let's just see. Let's color these in. So dark, medium, light, green, red. I guess we missed pink. Pink, orange, blue, yellow, and red. Not red. We already did red. Okay. Obviously, none of these can be 7. I guess this could be 7 if that's the case. This one cannot be 7. We tried that already, right? Yeah. We had, what was it? 7, 7, 7. Then these can't be 7, so this is 7 here. This must be 7 here. This becomes 5. None of these could be 7, so 7 here. Then the problem is this 7 sees all of these cells. So that's not possible. Again, if this is 7, though, could this be 7? No, this could not be 7 either. Because if this were 7, this A would have to be here, guaranteed. Right, because this couldn't be 7 anymore. It would be 8 or 9, and 8 and 9, the 8 or 9 has to be there. So again, if this is 7, this can't be 7 here. This becomes 8 and 9. This becomes the A, 8 or 9. So 7 cannot be here, so this must be the 7 here. So the question is, can we reach a contradiction here? This must be an 8-9 pair, which means this has to be 7 here. We're guaranteed a 7 in one of those two. This can't be 7, this can't be 7, so 7 has to be there. This is 5. And then this would have to be the 8 or 9. But then we'd have a contradiction, right? Because this cell, if it's 8, yeah. If it's 9, obviously this can't be 9. Well, that's okay then. Um, This becomes an 8-9 pair. So this would be 7, 7. No 7 here. One of those two is 7. So no 7 here, no 7 here. This is 7 here. This would be A. This would be A. This would be A. This would be A. So this would not be 8 or 9. No 7. Therefore, so then what? This would be 6. This would be 1. So I think all scenarios, this is never 6. This is never 6 here. Wait, why couldn't this be 7 there? Maybe it could be. Well, okay, what happens if this is 6? If this is 6, this becomes 6. This is 1 and 6. This can no longer be 8 or 9. Because the 8 or 9 would have to be here, cannot be here, would have to be here. So this has to be 7. Which means this can't be... So this can't be 1, this is 1. This can't be 7. Because this can't be 7 if this is 7. So if this can't be 7, this would have to be 8. So it's a 7-9 pair here, which makes this 8. That makes that 8. Makes that 8. But isn't that the... Okay, so this can't be 8. This is 9. That's 8. This is 9. 7. But this would be a 1-7 pair here, which would be a contradiction. Okay, so there we go for that. Okay, so this cannot be 6. I think so therefore 6 is always guaranteed to be here. This is 1, which means this can't be 1 here. This has to be 1 here. This is 7, 8, or 9. So the A is only for when it's 8 or 9, right? We don't have a guarantee on 7. Well, 7 and 8 work here, right? So the question is, why can't this be 7? Oh, because it's always A. If this is 7, this can't be 7 here. Because we've shown that that doesn't work. Because then that would have to be 7, and that would fail. So if this is not 7, this is 8, and this would be 8. So this would not be 8. I guess the question is, why can't this be 9 is kind of the question. There's a lot of logic here. Oh boy. Okay, 8 works, it seems. 8 seems to be the solution. Why can't 7 work here? Okay, so if 7's here, obviously none of these can be the 7's here. We have to have a 7 that disqualifies 2 of these 3x3 squares. So it's either here, here, or here. If we have a 7 here, A can no longer be here. So these can never be 7 if that's the case, right? So if this is 7, the problem is the 2 that 3x3 squares that are removed are both of these ones that contain this 7, right? Because this is 7, that's 7. This 3x3 square and this 3x3 square are the ones that cannot have a 7, so this can't be 7, so 7 would have to be here, but then this 7 would eliminate those. This would eliminate 2 more of the 3x3 squares, which would leave 5 3x3 squares which do not have a 7. So that's why this can't be 7, and that's why this can't be 7. Because if we have 7, 7 here, then A has to be here because it's 8 or 9. And if it's 8 or 9, it would have to be there. And that's already a contradiction. So neither of these could be 7. So if we tried 7 here, 7 can't be here, 7 can't be here. So this would have to be 7 there, which would leave 7 here. This would be 8 or 9. So this would guaranteed to be A. This would be A. This would be A. This would be A here. Okay. So then 7 would have to be here. Because there would be no other place for it in these cells. Because it has to be here. So we have 7, 7, and then that's 7, which makes this 5. So far, that's okay. One of these two is 7. So there's no 7 here. This can't be 5, which makes this a 5 here. No 5 here. This is not 7. This is 8 or 9. This is not 7, not 7, not 7. This can't be 6 or 7. It's A. This can't be 7. It's 6, 8, or 9. No 7. It's 8 or 9. No 7. No 7. No 7. This is A. 8 or 9. 7 is one of these two. No 7. 7 here, 7 here. This can't be 7, so 7 must be here, which means this can't be 7 here or here. So this is 7 here, and we have a contradiction. So in column 9, or box 9, 7 can't be here or here because of 7's in the columns. 7's can't be here or here because of 7's in the rows. That's kind of a long, convoluted way of solving that, but okay. Bifurcation. You'll eventually have to do it eventually. So that's why this cannot be 7. So this has to be 8. Which means if this is 8, this has to be the 8 here, which eliminates the 3x3 box of the light cells. Every other light cell cannot contain an 8. So this can't be 8, this can't be 8. Obviously none of these are 8, and these can't be 8. So since this is 8, this cannot be A, because if A cannot be 9, because that would require an 8, an A here. That's the reason why it can't be 9. So then this is 7. We don't know if this is 7. This 8 eliminates 8 here. Here. So this has to be 8 here, which means this cannot be 8. And if this were 7, that would eliminate a lot of 3x3 boxes. So that would eliminate this 3x3, this 3x3, and this 3x3 already. So this can't be 7. This is 9, which forces this to be 7. This is 9. So this is 8 here. This can't be 6 or 9, so it's 7. This can't be 7 here, so it's a 6-9 pair, which eliminates 6 and 9 in the rest of the columns. Can't be 9. It can't be 7. This is 8. That means this can't be 8 here. There's no 8 here, 8 here. This is a 6-9 pair. Let's remove the coloring. So 7s. This can't be 7 or 9. It's 8. There's no 8 here. It's 5, 7, 9. No 8 here. So this 7, so this does not have another 7. No other 7 here. If the 7 were in the corner here, right, it could have been in 2 corners, I guess. But the thing is, there was never 2 corners available. So the problem is, if there's a 7 here, it removes one 3x3 box, but then the other 3x3 box, where is it taken from, right? So this can't be 7, which means one of these two is 7, so this cannot be 7 here. This must be a 7, yeah, 7 eliminates 7 here anyway, so this is 9, this is 7, there we go, that's a 7x7. That removes the 3x3 boxes there. This 9 eliminates 9 here, so it's 6 and 9. 6 eliminates 6 here, so it's 1 and 6. No 6 or 7 here, it's 9. Which eliminates 7 and 9 here, it's 1. This has to be a 5-8 pair. This cannot be 9 or 8. This is a 6-7 pair. There's 6, 7, or 9. This becomes a 5-8 pair here. No 8 and 9 here, therefore this is 7, which means this can't be 7, that's 5, which means this can't be 5, that's 9, this can't be 5 or 9, it's 7. 9 eliminates 9 here, so it's 7, that's 5. 7 eliminates 7 here, so it's 9 and 7. This can't be 5 here. This becomes an 8-9 pair. 9 eliminates 9 here, so it's 8 and 9. 8 eliminates 8 here, so it's 5 and 8. This can't be 5, it's 9. 5 can't be here. No 6, 7, 8, or 9. So this is 6, this is 5. This can't be 7 or 9, it's 8. So let's just double check these. This 8, 1, 2, 3, 4, 5, 6, 7, 8 3 by 3 squares, which do not contain another 8. 7 has these two missing, so it's missing 1 and 2. And every other 7 by 7, every other 3 by 3 square has no 7s. 5, we have 1, not here, not here. 2, 3, 4, not here, not here, not here, and then we have 5. So that should be everything. So this is 6, and that's 7 in the corner. Yeah, kind of complicated. So, yeah, the 1 through 4 parts were fairly simple. But once we started getting through the 5 and 6, we had to go through a decent amount of essentially bifurcation. It is what it is. That is the case. A lot of people in the Sudoku community don't like bifurcation because it's, I don't know, not elegant, I guess. It is what it is, I think. It's just basically sometimes you have to bifurcate and try things out. Go down one path, see if it works out. If it doesn't work out, you must go down the other path then, right? Or if you happen to choose the correct path, then you have to find the contradiction down the other path, right? To make sure that that's correct. But anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.